Hello, good day viewers. In this tutorial, we are going to find a solution to this Diophantine equation. We want to find the values of a and b that will satisfy this equation 9 to the power of a minus 4 to the power of b equal to 17, for which both a and b are all positive integers. Alright, let's get started. I know that 9 can be expressed as 3 squared, so we have 3 squared, but because of a, we multiply by a, minus 4 can be expressed as 2 squared, so we have 2 squared, but because of b, we multiply by b, and this is equal to 17. I can rewrite this as 3 to the power of a, but raised to the power of 2, right? This is one of the laws of indices, minus 2 to the power of b raised to the power of 2, and this is equal to 17. Now we have difference of two squares. You can see this is squared, negative sign in between them. So we can factorize it as we take the first term, 3 to the power of a, we add 2 to the power of b, then we multiply by 3 to the power of a minus 2 to the power of b. This is how to factorize difference of two squares, and this remains 17. So what can we do next? Now we have two factors multiplying each other, and the result is 17. 17 has only two factors, 1 and itself. And by clear observation, you should know that this must be greater than this, right? So if this is greater than this, we can equate this to 17 and equate this to 1. That is 17 times 1 equal to 17. So we have 3 to the power of a plus 2 to the power of b multiplied by 3 to the power of a minus 2 to the power of b to be equal to 17 multiplied by 1, and hence we can say that 3 to the power of a plus 2 to the power of b is equal to 17, and 3 to the power of a minus 2 to the power of b to be equal to 1. And now we can solve this systematically. What can we do? We can add the equations. If you add these two together, you have 2 of 3 to the power of a. Once you add this together, you get 0. This is 17 plus 1 is 18. From here, you can divide both sides by 2. We have 3 to the power of a to be equal to 18 divided by 2 is 9, but 9 can be expressed as 3 squared, so 3 to the power of a is equal to 3 to the power of 2. The bases are the same, which implies that the exponents are also the same. So we have a equal to 2. So we have gotten the value of a. Let's go back to that system of equation. This time around, I would like to subtract. So I would like to subtract. If you subtract these two equations, this minus this will give us 0. This minus this will give us 2 of 2 to the power of b. And this is equal to 17 minus 1 is 16. Divide both sides by 2, you have 2 to the power of b to be equal to 16 divided by 2 is 8. But 8 can be expressed as 2 raised to the power of 3. So 2 to the power of b is equal to 2 to the power of 3. The bases are the same, which implies that the exponents are also the same. So b equal to 3. So we conclude that ab, which are the values we are looking for, a is 2, b is 3. But we can check them in the main equation to see whether this is true or not. The main equation is 9 to the power of a minus 4 to the power of b. Let me just copy that. So now let us substitute the values of a and b in this equation to see whether we are going to get 17 to the other side. So this is 9 to the power of a, which is 2, minus 4 to the power of b, which is 3. Is this equal to 17? 9 to the power of 2 is 9 times 9, which is 81, minus 4 times 4 times 4 is 64. Is this equal to 17? There is question mark. If you subtract 64 from 81, definitely you have to get 17. 17 equal to 17, which implies that the values of a and b are 2 and 3 respectively. Thank you for watching. Do share to your learning colleagues. And don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.